Let's begin. Okay. Yay.
Absolutely. Okay. Hello, everyone. I am James Snell, or J.A. Snell, pretty much anywhere online. I am a core contributor to Node. I am on the technical steering committee for Node. In there, I've been involved with that project for about 8 years now. um, Doing quite a few contributions there, things like HTTP2 and URL parser, and I mean, quite a few little bits and pieces that are there. I am also for just over a year now. I've been on the Cloudflare Workers team. I'm a principal systems engineer there. I actually work on the Workers runtime itself and the part that we just recently open sourced, which is called Worker D. Um, I been involved with that, like I said, for just over a year, working on all of the various standard APIs, things like streams, and a lot of the stuff that I'm going to be talking about here today. So that's where I'm coming from. You can find me on Fostodon. I'm over on Mastodon. I was on Twitter. You can still find me on Twitter, but I'm not using that these days. Or of course, you can find me on GitHub as well. So please feel free to reach out if you have any questions on any of this stuff, and want to kind of follow up. All right, so what are we talking about? We have this this concept of a web interoperable runtime. And I just kind of want to expand what this is, what it means, and kind of why it is important for JavaScript developers. So let's take it back. In the beginning, there was Node. Node's unbelievably about almost 13 years old now. It's been great. Pretty much everyone's using it. It's not going anywhere. It's just going to keep right on marching forward. And as I was reminded, when I came into the project, it was 2015. I was told this a lot. This concept that Node is not a web browser. Why should it act like one? There's always been this separation between what the JavaScript you write in a web browser and the JavaScript you would write in Node. And it was always positioned as being two completely different environments, two completely different sets of use cases. And you just wouldn't want to write code that works in Node that works in a browser, right? And why would Node ever need to act like a browser in terms of providing the same APIs? And what we find is, kind of building on that idea, is that Node has its own set of APIs for everything, right? Its own events API in the form of event emitter, its own streams. You have stream readable and stream writable, right? It has the buffer API. It has its own way of doing HTTP requests, right? Networking APIs, compression, right? Its own crypto API. All of these things are very specific to the way Node works. Now, to be fair, when Node emerged, there were no standard APIs for a lot of these things, right? Buffer was introduced into Node before units 8 array and typed arrays existed in the JavaScript language. The URL.parse method existed long before the new URL constructor and that URL object. So there was a time when Node needed to introduce these concepts and needed to introduce APIs that were specific to Node. And for the longest time, this was considered to be just fine, right? Like I said, folks saying, Node is not a web browser, so why does it need all of those same APIs? Except during this time, as we're talking about all this and saying, okay, making this argument, Node is not a browser, we had developers busy writing polyfills, right, their own implementations of Node specific APIs that would work in web browsers. And today, if you look at npm, you'll find that there are a lot of these polyfills are downloaded millions of times each week. They're used extensively throughout throughout the entire ecosystem, right? And conversely, writing polyfills of web browser APIs that work in Node, right? So those of us that are actually working on the runtime have this idea: no, these things shouldn't work together. But the developers actually out there building applications are essentially, are you crazy? We need this, right? We need these things to work together. We only want to write this code once and have it work in both of these environments. So you have this dichotomy, this two different conversations that were happening. One, the runtime's just doing their own thing, and the developers that were wanting a lot more. Instead of just simply writing APIs that would work in both, that would just simply be there and be available, and it would just work. It takes me back to like the very first web platform API that we introduced in Node. Well, not the very first. I mean, there's console that's been there. It's kind of been compliant to the spec for a while. But we always had url.parse, right? As the way of parsing, these simple URLs. But it had a number of problems with it. So I think it was back in 2016. I was going to make some changes to it and decided, why not just implement this standard spec, this new URL class that the WhatWG had defined, and let's just see what happens. And I honestly had several other Node core contributors at the time actually yelling at me at a conference, like in person, in my face, yelling at me for wanting to add this API and add a couple other APIs, because of this idea: why should Node be like the browser? Why would it need these APIs? And it didn't make any sense. Right. So it's been a long road. We've made some progress. We're going to talk about some of that progress here. But this idea of just hey, maybe these APIs could work in all of these different environments. Now today, thankfully, Node is no longer alone. Right. Node's not the only non-browser JavaScript runtime out there. Very importantly, we have Dino, right? We have Bun, and a very exciting new platform coming up and coming. We have Cloudflare Workers and Workerd. We have Vercel's Edge runtime. There are many of these things starting to emerge, right? And I'm super excited. I was looking at the schedule for the talks, and there's talk. You have talks on Dino and Bun and Workers. I mean, all of these things are being not only are they starting to emerge, but they're starting to be used, and really starting to gain momentum in the ecosystem. And I, as a Node core contributor, when Dino first came out, I had folks asking me if I was worried that Dino was going to take over, or that Node was going to go away. And no, I'm not worried at all. The emergence of these other runtimes actually builds a much healthier ecosystem for everybody, including Node. It ensures that things aren't going to get stagnant. They're not going to get stale. The entire ecosystem is going to continue to evolve. And this push towards these web platform APIs, that is part of that evolution. That's part of the maturation of this entire ecosystem as it moves along. So in everything, when we see across all of these runtimes, developers want the same APIs to work consistently across all these JavaScript runtimes. They don't want to have to do something one way in Node, another way in Dino, another way in the browser, right? It doesn't make any sense. Why should the way that you parse a URL be different when you're just writing JavaScript, right? So very important that we, as the people that are building these runtimes, actually pay attention to this concept, that this is what developers want. This is what they've been asking us for. This is why all those polyfills exist, right? In Workers right now, we have developers that are coming to us constantly, Cloudflare, saying, hey, there's all these modules out on NPM. Can we just run those in Workers? And unfortunately, for a lot of the cases, we have to say no, because all of those were written to Node APIs, right? That's a very specific platform. That's that thing. And we're going to be doing some work to support those. It's fantastic to see that Dino is starting to support NPM modules now. In workers, we're going to be doing some work over the next year to support those also. But wouldn't it be better if, we didn't have to go off and support Node APIs, right? It'd be better if it was just we're writing the standards, right? So that's what we're focusing on. So the other core concept is, yes, Node may not be a web browser, but it still does a lot of the same stuff web browsers do. There is a significant overlap between those environments, right? No, we're not rendering web pages, but we are parsing URLs. We are handling events. We are handling streams of data, right? We're sending HTTP requests. We're compressing data, decoding characters, strings, all these kind of things. This is all things that we do in all of these different environments. Why should we have different APIs for these, right? So that's really what we're focusing on. A web-interoperable runtime is one that implements all of the APIs for these in a consistent way. It doesn't matter what runtime you're using, right? They should work the same way from one to the other. And your code, you should be able to write it in one, move it to another, and still be able to reasonably expect that it works the same. Runtime specific APIs for common functionality are an anti-pattern we should not continue. Anytime you see Node or Dino introduce this, a platform specific API that says, well, wait a second, don't we have to do that over here also? You should immediately just say, nope, let's have a standard for this, right? This is not something that we want, as developers. So earlier this year, while working at Cloudflare, we started looking at this problem, and we realized with workers, we wanted it to be standards based, but we realized this is not a conversation that we could have just, by ourselves, right? So we went out and we talked to some folks, some contributors to Node and contributors to Dino and contributors, to other runtimes around, including Bloomberg and Vercel and folks from a bunch of different companies around the ecosystem. And we started talking to them about this idea of this web-interoperable runtime and what it means and how do we define that. And more importantly, how do we work within the framework of existing web standards to start having a useful conversation? If you look at the charter for groups like the WhatWG, the working group that builds and defines a lot of these standards like streams and URL and fetch and that kind of thing. If you look at their charter, they are specifically limited to only paying attention to the needs of web browsers. It's actually spelled out very specifically that web browsers are the only use cases they care about. So, someone from Node come and said, well, hey, can we have this new URL API? They look at it and say, well, that's not really interesting to browsers, so no. It made the conversations very, very difficult, because, each of these individual runtimes, Dino, Node, and all these others, would go and have individual conversations with WhatWG and the W3C and be like, well, we like that. We don't know if the other platforms would, but we think it's useful. And it's not very, not very helpful. It doesn't get a lot of, we don't accomplish much going one at a time, going and talking to them. So the WinterCG, this Web-Interoperable Runtimes community group, is all of these platforms coming together with one voice to talk through all of these APIs. Which ones should we implement? How should we do it? How do we ensure that they're interoperable? And how do we collectively go and talk to the WhatWG and the W3C and and basically the web browsers and say, hey, we have a stake here also. We have an interest in moving this forward. We want to be compatible. We want to be able to interop with you, right? How can we do it in a way that allows us all to move forward, right? So that's why WinterCG was formed. Now, one of the very first tasks, one of the very first things that we did with this working group, and this is an ongoing thing. This document is still in evolution. But we created this thing called the Minimum Common Web Platform API. And essentially what this document does is define a subset of the web platform APIs that should be supported by all web interoperable runtimes. If you go out on the MDN, Mozilla's documentation for all of these JavaScript APIs, if you search there for web API, right, you will get a single page that has hundreds of APIs that are listed. It's all of the classes and all of the functions that, in all the specifications that web browsers support, right? Most of those are not relevant to environments like Node. Node doesn't do any DOM rendering. Dino is not rendering iframes and those kinds of things, right? So a lot of those APIs just simply aren't relevant. So what set of APIs are relevant? Which ones do need to be implemented on environments like Node and Dino and these others? That's what the minimum common web platform API defines. So what is included in that? Well, it turns out there's quite a bit. There's a good amount, right? So we have things like abort controller and abort signal, right? This is the standard way of canceling asynchronous tasks, right? So if you want to do a fetch, but it's taking too long, so you want to cancel it, right? That you use an abort signal for that. All of the streams APIs. So we see on here writable stream, readable stream, transform stream, a whole bunch of other classes that are tied to that whole specification. Those should all be there. Event handling, event and event target, right? All of these runtimes should have these APIs. If you're doing data compression or any kind of data manipulation, whether it's decoding text, compressing text, right? There are standard APIs for these that exist. They work very well. Let's make sure that those are available. Cryptography, right? The Web Crypto API. Personally, I don't think it is the best API for doing crypto, but it has the advantage of being standardized. It has the advantage of being integrated well with promises. So it kind of fits in with those language primitives. So it's there, it's available, right? And it should be across all of these, consistent across all of these applications. But even things as simple as, timers, set timeout, set interval, or cloning data with structured clone, right? Or even knowing which runtime you're running on, right? Node has its own API for saying, hey, I'm Node, right? Dino has a separate API for saying, hey, I'm Dino. That doesn't make any sense, right? Navigator.userAgent gives us something very simple that we can say, great, it doesn't matter what platform I'm running on. I can use this to determine what runtime my code is using right now. All right. So all of these APIs make up what what we currently define as this minimum common web API. All right. Now I'm happy to say that this year, over the past year I've been with Cloudflare, we have got where all of these APIs are implemented in Cloudflare Workers, either fully compliant or nearing compliant to the specs. I can also say proudly that most of these APIs, I think all of them except URL pattern, are also available in Node now. They're also available in Dino. I believe Bun is either on the way or close to implementing all of these. So we are very quickly over this past year approaching this goal of having this common minimum API surface that's just there and available in all of these different environments. And personally, I find that very exciting. All right. Also importantly, you should not have to go to Node's website and look up Node's documentation on how text decoder works, right? Because it shouldn't be specific to Node, right? You should be able to go to MDN, say, okay, look at the standard documentation for text decoder, write some code to that, and have it work in Node, in Dino, in Workers, in all of these environments. It should just be consistent. All right, so one important omission from that list, you might notice that fetch is not there yet. It will be soon. So if we look here, you don't see fetch anywhere on this list. The reason for that is fetch currently includes this. I'm going to talk about the specification, the standard currently includes requirements that are not relevant to non-browser runtimes. So I'm talking about things like cores and cookies and some of the way that global state is required to be managed. A lot of that is not relevant to environments like Node. When I say not relevant, imagine, usually a web browser or browser tab only has a single user at a time, right? That global scope is only shared by one person. On a server like Node, where you have, millions of requests going through, you can have literally millions of users sharing the same global scope. It doesn't make any sense to have cookies and cores in details and that connection state at that global scope, because we can run into all kinds of issues. So what actually needs to happen, and this is something that the working group is working on right now, is defining a subset of the fetch API that is specific to non-browser runtimes. And the way that we are doing this is we are actually going to pull up the actual, the actual spec produced by the WhatWG, and we are going to go through line by line, and basically, the parts that aren't relevant to anything other than a browser, we're just basically going to cross those out, right? And just say, Node, Dino, you don't have to worry about implementing this part. But the sections that are relevant, we'll highlight those and say, but you do have to pay attention to this piece. And once we have that annotated version of the specification complete, we're going to go back to all the runtimes and say, fantastic, now implement to this. And make sure that your implementation of fetch, which is now available in all the runtimes, make sure your implementation of fetch matches this subset of the specification. And once we do that, fetch will be added to this list of all of the APIs. Now, importantly, I'm going to talk about, kind of what, how does something get added to this list, right? When we put this thing together, it was a very simple algorithm that we used. Essentially, if any of these APIs were implemented in at least 2 runtimes, it got added, right? So, Node had readable streams added in 2001. Dino has readable streams, or the web streams API, and Workers has the readable stream API. Fantastic. It's added to this list. URL pattern, Dino has it, Workers has it, but Node does not. Even though it's not there in Node, and it's not clear when it's going to be, it still meets the requirements for adding to this list. At least 2 runtimes have to have it available and have it be compliant to the specification. All right, so that's the rule. So that's as we move forward, that's what we're going to follow. Now, the other important thing is WinterCG going to focus on the creation of new APIs? Is it going to be a source of new specifications? Well, what WinterCG gives us is a venue for talking about those, about making sure that we have agreement on what new specifications or new APIs should be. But our plan is not to write specifications ourselves within the WinterCG. The plan is to take those ideas and go to the W3C or go to WhatWG and say, hey, we have this idea for a common API standard that we all think is important. Can we get this standardized under your process? So the WinterCG is not going to go off and become yet another standards body on its own. The intent is to work within those existing frameworks, those existing organizations, to make that stuff happen. Now, importantly, you can help. WinterCG is open to everyone. All the work is being done on GitHub. We have a call that we do every 2 weeks The time is, unfortunately, right now is not a great time for folks in Asia. It ends up being, quite late in your evening. But we are going to be moving that and shifting to an alternating schedule where we'll have one meeting at a time that is convenient for Europe and Eastern U.S., and then another meeting that's more convenient for Asia and Western U.S. So we're going to be, kind of, alternating those out and figuring out that schedule. But we want more people to come into it. We want you all to be involved. And we are very excited to see where Winter CG is going. Thank you very much, and I hope you all have a fantastic rest of your conference.
Thank you so much. I enjoy so much. Yeah, I didn't know some stuff like, so if we would be better, if we need to define some new APIs, and then so some two other runtime engine uh, implements the API. So yeah, I didn't know that. Yeah. So yeah.
Yep.
So is that just two or three? And so how many how many engines?
Right now it's two. But as the number of runtimes grows, like when we first started talking about this, it was pretty much like Node and Dino, right?
I got it.
But more have started to come in, and so we may expand that list or that number.
Yeah, I didn't know this type of stuff. Yeah, so thank you so much for this for this presentation. Yeah, I enjoyed so much. Yeah.
Yeah, absolutely. Well, thanks
And
for having me.
thank
I love
you.
talking about this stuff. Yeah.
Yeah. See you again. Yeah. See you. Bye.
Bye-bye.
Thank you.